Today we're going to talk about functions. All of the example problems in this video are from Delta Math, grade 8 functions. So we're going to start by analyzing graphs. So here is a graph, and they have asked us when is this function decreasing and nonlinear. So decreasing would mean going down on the y-axis, and nonlinear would mean not a line. So something like curvy, anything that's not a straight line. So the first thing I like to do is find those spots. So I'll grab my green pen and I'll say, well, this one is going down. Remember, we read from left to right, so that's important as far as going down or going up. So you're reading from left to right. So that one is going down and it's nonlinear. And that's the only one that I see because I look at this other one on the right and I see that it is indeed nonlinear, but it's going up when we read from left to right. So that is not going to be a choice. So now I need to ask myself, when is this going down and nonlinear? And I'll use my green pen again and I'll say here at -9 is when it starts that descent and it stops at -3. So I'm looking for x's that are between -9 and -3. So right away I can rule out these two choices, and then I can rule out this one as well because I have a 0 and -3 is on the wrong side. So the way I read this is my x's are between -9, they don't include -9, and -3. So my choice would be between -9 and -3. On this one, they're asking, is the function linear? So I have been given ordered pairs and I'm being asked which one is a linear function, which one looks like a line, which one fits the equation y equals mx plus b. What I need to know, what's most important, is that it has a constant rate of change or a constant slope. And there's several ways to find slope. When it's on the graph, rise over run. When it's listed as ordered pairs, it's your change in y over your change in x. And that's denoted with the delta sign. Another way to think about this is your y2 minus y1 over x2 minus x1, which is just another way of saying the change in x and y. So to be linear, it needs a constant rate of change. It means the same. So I'm going to take a look at my x's and I'm going to say, look, from -2 to 0, I'm adding 2. From 0 to 2, I'm adding 2. From 2 to 4, I'm adding 2. So my x's are adding 2. My y's will switch to red. It looks like I'm going from 2 to 1. I'm going down 1. I'm going down 1. And I'm going down 1. So my rate of change, my change in y is my red. Whoops. And my change in x is my blue. So my rate of change there is -1/2. So that is my linear function. Let me find another one and just show you why it's not linear. So let's look at choice C. So we'll do the same thing with our reds and our blues. So from 2 to 4 plus 2. From 4 to 5 plus 1. 5 to 8 plus 3. That does not immediately rule it out. It could turn out to be a constant rate of change, so don't stop there. Here, your y's, -2 from 5 to 3, -2, that does rule it out. Because when you have your change in y over your change in x, it has to be constant. And in the first one, it's -2 over 2. The second one is -2 over 1, so that is not linear. We could do that for B and D and we'd find the same things, that they turn out not linear. Let's look at the next. So now we have another way of representing this. It's slightly easier to see it in a table form. So you're still looking for a linear function. That means a constant rate of change. That means your change in y over change in x is the same. So each time I'm going to check. So my change in x, -1 to 1 is +2. 1 to 3 is +2. 3 to 6 is +3. My y is -7 to -2, or -7 to -2 is +5. -2 to 3 is +5. 3 to 8 is +5. I immediately see a problem because my change in y is going to be 5 over 2 in the first case, 5 over 2 in the second case, and 5 over 3 in the third. This is not linear. Let's look at choice B. From -3 to 0 is +3, +3, +3. Negative 2 to 1 is plus 3, plus 2. Again, not equal. The first time it reduces to 1. 3 over 3 is 1. 3 over 3 is 1. 2 over 3 is not 1. Okay, let's look at choice C. So the same process each time. So negative 9 to negative 4 plus 5. Negative 4 to 1 plus 5. 1 to 6 plus 5. Then here you're going down by 1 each time. It looks like I have found my winner. My rate of change, my change in y over my change in x is negative 1/5. Next page, write the equation in slope-intercept form. So now remember, all lines are y equals mx plus b. So we've been tasked with finding two things. We want to find the slope of this line and where it crosses the y-axis. I'm going to draw a set of axes just to show you. Here's your x, here's your y. Where it crosses the y-axis, let's just say this is a line going in both directions, would be right here. And the thing to know about that is the value x equals 0. So x is 0, then 1, then 2, then 3. But if you follow this up, the place where it crosses that y-axis always for every line is where x equals 0. So we can read this straight off the table. Where x is 0, y is negative 2. That means our y-intercept, or our b, is negative 2. So I would build out my equation. Y equals mx. Instead of plus b, I know it's negative 2, so minus 2. Now I just need to find my slope, or my rate of change. Remember, that's change in y over change in x. So I'm just going to check. Each time I'm going up 1. They tell me it's linear, so I expect this to work out. From 28 to 38 is plus 10. 18 to 28 is plus 10. 8 to 18 is plus 10. Negative 2 to 8 is plus 10. Be careful. You want to double check that your slope is indeed change in y is 10 over 1. So it's 10. You don't have any reduction to worry about. So your slope is 10. So you replace your m with your slope. So this equation is y is 10x minus 2. Okay, they could ask us to compare, and I think this is where it gets fun. So they tell us that the top one is a linear function, so that means it's a line. We could write the equation, I think we will, and then it says which one has a greater rate of change than the one above. So we need to find the rate of change for the one above. So I'll zoom in on this, and I know my change in x is going to go up by 4. They tell me it's linear, so I'm not checking. I'm just finding the slope. Negative 1 to negative 2 is going down by 1. So my rate of change, my change in y over change in x, is negative 1 over 4. So my slope is negative 1/4. Now, my y-intercept is where my x is 0. So I can write the equation. So y equals mx plus b. I found my slope was negative 1/4, so y equals negative 1/4 x. My y-intercept is negative 1. So now I have the equation. It says which one has a greater rate of change. Remember, rate of change is slope. It's your m. Negative 1/4 and negative 1/4 are the same, so this one does not have a greater rate of change. Choice B is a positive slope. It's going up 1 and over 4. So this is a positive 1/4. That could be a greater rate of change. Keep that in your pocket. Now look at letter C. This is a negative slope. It's going down 1, 2, 3, and over 1. Down 3 and over 1. That's a negative 3. And choice D is a negative 5. Now this is where you really do have to understand the number line, because you have a slope of negative 1/4. Let's draw a number line here. You have 0, and let's go down to negative 5. Negative 4, negative 3, negative 2, and negative 1. So negative 1/4 is right about here. Negative 3 is right about here. And negative 5 is right about here. You might be tempted to think that the greater rate of change would be further negative, but your greater rate of change is actually bigger, closer to zero. It's on the positive side. So your greater rate of change would be choice B. And now our last one, our real world rate of change. So here you have to look at your X and your Y, finding the rate of change, hours and miles. So every 4 hours plus 4 plus 4 plus 4, what's happening? It's going up. This way you might want a calculator, but you might be fine. So you've got 40,000 to 60,000. You probably can tell that's going up 20,000 miles. So 20,000 every time, 20,000. So your rate of change, here you have to reduce. Your change in Y is 20,000. And your change in X every 4 hours, that looks like a Y. I don't want a Y, I want an X. I went to put a 4. So 20,000 over 4. So you've got your 20,000 divided by 4. So you find out that it's 5,000 miles per hour. That's what it reduces to. And think about that. That is a space shuttle. So that makes sense. A car, you would be going like 50 miles an hour. Okay, and that's our function practice. Thanks for watching.